Okay, this video today is going to be talking about parabolas. Well, in the past, parabolas, we've dealt with the general equation or the parent graph y is equal to x squared. And we can graph this quickly knowing that the vertex is at 0, 0, or if we wanted to go ahead and plug in 0, we got 0 out. Plug in 1, we get 1 out. Plug in, say, -2, we get 4 out. And realize that it does open up. It is a function, and it is symmetrical about the y-axis. But what I really wanted to do today was kind of talk about, in general, the focus and really what the definition of a parabola is. Definition of a parabola is really all the points that are equal distance from a point to a line. The point we're going to call the focus, the line we're going to call the directrix. And so what we'll do here is we'll take and say the vertex is at 0, 0. Okay, just like we did that, nice and easy. And what we're going to do is we're going to put the focus and we're going to make it open up. And the focus is, and we'll talk about that here in a second, this is the focus. And then we're going to put the directrix down here. Here we go, the directrix. And we're going to say that all of the points that are equidistant to both this point and this line, the focus and the directrix, is going to give us a parabola. So the first thing we're going to do is we're going to kind of derive how do we get the distance between the focus and the vertex. Well, we're going to call the distance between the focus and the vertex P. So therefore, down here, the distance between the vertex and the directrix is also going to be P in the negative direction. Okay, that's the definition, that the vertex is equal distance to the point and to the directrix. But there's also other points. There's points up here that will be equidistant. There's points, if I go over here enough units, say right here, if I go over this many, we'll say that's 8. I don't know. This down here looks about the same distance, 8. So that's going to be on there. But we'll get back to that later. What we're going to do here is we're going to say, okay, well, let's come out and say we have a parabola. Say something like that. Okay, and now we're going to pick another point on that parabola. So we have the focus, and we have, say, another point we'll put all the way up here. We're going to generically call that xy. And basically what we're going to be doing is let's go ahead and pick up a generic point. If the focus or the vertex is at 0, 0, the focus must be at 0 and then up p number of units. So it's 0p. The coordinates here is xy. And now this distance, let's see if I can draw a line from here to here. And this distance from here to here must be equal, congruent. So we can say the distance between this point, the focus, and the generic point xy must be equal to the point xy and the directrix. Well, let's look at this distance right here. Well, if this from the vertex to the directrix is p, then if I split up this total distance, this right here is p long. And if I look at this point, in order to graph it, I go x this way, and then I go y vertically. This segment right here must be y. So the total distance right here from the point to the directrix must be y plus p. The total distance from the focus to the point, well, I don't really know that, and I got to do the distance formula. Remember, the distance formula is the change in x plus the change in y square root. So basically, we're going to do x minus 0 squared plus y minus p squared, square root all of that. That is the distance between those 2 points. Now the other side distance between these 2 points is y plus p, and the definition of a parabola is all the points that are equidistant to a point and the line. So real quick, I'm going to go ahead and simplify this, and you're going to see how magically we can come up with the focus by just getting the equation. So the first thing I'm going to do is I'm going to go ahead and square both sides. When I square both sides, the squared undoes the square root. So I'm going to be left with, this is really just x squared. And then if this is y minus p quantity squared equals y plus p quantity squared. And now if I go ahead and expand this, I get just the x squared. Go ahead and expand this. This is a y squared minus 2yp plus p squared. That's what this is expanded. Look up in the expansion of binomials if you forget. If I expand this on the right, I get y squared plus 2yp plus p squared. Now all I need to do is simplify. I have a p squared on both sides, so let's use a different color. I have p squared here. If I subtract a p squared from both sides, that's gone. If I subtract a y squared from both sides, that's gone. Now, I'm going to go ahead and now just add 2yp to both sides. So I have 2yp to both sides. So I'm left with x squared is equal to a total of 4yp. And this 4, I guess I can also rewrite it as 4py. And so now this 4 is really going to give us our general term. So let's do a couple examples. So let me go ahead and erase everything, and then we'll start with a couple examples. So erase and delete. There we go. Oh, I left a little bit at the top. There we go. Okay, so now what we're going to go ahead and do is to say, let's say we have x squared is equal to, I don't know, 8y. Well, couple things. If I'm graphing this, what I'm going to look for is, number one, I have y is equal to x squared. That's what we knew and loved before. So that, because this is positive, it opens up. So I always make myself a nice little picture. But what we're going to do is we're going to say the generic form we just said from before was x squared is equal to 4p times y. Well, if this is the same exact form, these must be equal. So 8 must equal 4p. Therefore, 3 dots, p is equal to 2. That is the distance, remember, from the vertex to the focus. So if I go to graph this, because I did not mess with y, because I did not mess with x, my vertex is 0, 0. Now if I go to graph this, so here is my vertex. Here we go. Because I'm opening up, I go 2 units up, and my focus is going to be 0, 2. I go in the opposite direction, 1, 2. The equation of my directrix is going to be, since it's horizontal, y is equal to -2. Now, in order to get 2 more points that are on the graph, what I'm going to do is use the focal width. The focal width is equal to 2p. Basically, I'm going to go 2p horizontally with the directrix. In this case, 2 times p, or 4 units over. So if here is my focal, I'm going to go 4 units this way. So about 1, 2, 3, 4. This is going to be a point on my circle. 1, 2, 3, 4. This is going to be a point on my circle. So my parabola, when I finally end up graphing, looks like this. Well, why is this such an easy point to graph, or 2 more points? Remember that any point, that a parabola is the group of points that are equidistant to the focus. This was a total of 4. And then vertically, this is p and this is p, so that's why this is 2p. That this is a total of 4, this is a total of 4, and sure enough, that's right. So that is one example. Let's go through one more that has a vertex somewhere other than 0, 0. In this case, let's go ahead and say, oh, I don't know, and let's kind of switch one around. So instead of we having y is equal to x squared, we're going to have x is equal to y squared. So y minus 4 squared is equal to, oh, I don't know. Let's go with 20 times x plus 2. So in this case, this is in the general form. Now my vertex, I can pull directly out of this. I have a leading coefficient of 1 here, which is I like, and then I have some other coefficient. But this coefficient to x is also 1. That's the general form of it. Now, what I'm going to do is I'm going to pull, just like circles, opposite of my x, opposite of my y to get my vertex. So -2, 4 is going to be my vertex. In order to figure out p, I set my coefficient equal to 4p. So p is equal to 5, distance from the vertex to the focus. Now, let's figure out the opening. I always make myself a nice little picture. So I just look at the general form. I have x is equal to y squared. That's backwards. So this is a horizontal, either left or right. Because this is a positive, this is opening to the right. If this was negative, it would open to the left, but this is a horizontal. So when I go to graph this now, I basically have set up a nice little axis, Okay, I plot the vertex, so -2, 4. Okay, I know it's opening to the right. And now I'm going to go 5 units. So 1, 2, 3, 4, 5 units. This is going to be my focus. I don't know why this is not working. Oh, it's because I'm drawing a line. That's always beautiful. This is going to be my focus. I go left 5. 1, 2, 3, 4, 5. This is going to be my directrix. Now, it's a vertical directrix because I'm opening to the right. Remember, this is my vertex. Okay, and now in order to graph, so I'm going to, from the focus, I'm going to go 2p this way, and I'm going to go 2p this way. Since p was 5, 2p is 10, so I'm going to go 10 up, I don't know, about up here, and I'm going to go 10 down, maybe about right here. I'm going to go from my vertex through that point, my vertex through that point. And now we could sit here and just count. Because my vertex was at -2, I'm going to move to the left 5. So I'm going to get that my directrix is x is equal to -2 minus 5 more, or -7. My focus is going to be -2 plus 5, since I'm moving this way. And my focus is going to be -2 and 5 is going to be giving me 3, 4. Okay, so you should be able to pull all of that out of the information. Okay, and the next video I'm going to go ahead and do is I'm going to go ahead and try to convert between ugly and nice form, and then maybe work a couple other problems. But this is the generic form of equations, and this is the part 1.